Hello, water managers and SWIMS users. I'm Russell Errett out of the Water Management Systems Division at the Hydrologic Engineering Center, and this presentation is covering ResSim within SWIMS. This is the second part of a multi-part video series to cover this presentation, so if you want to see the previous video, check it out in the playlist below. So we're covering kind of the basic concepts of ResSim within SWIMS for real-time reservoir operations. We just went through the introduction of ResSim, what ResSim is, what it does, and how we use it within SWIMS. This part of the presentation, we're going to go over how to integrate ResSim within the CABI within SWIMS. So kind of a crash course on how to import ResSim model. And then we'll cover using ResSim for real-time decision making, some of the reports, the plots that you can look at, and then how to do release overrides within ResSim. So integrating ResSim model into SWIMS. So in an earlier presentation, we were talking about integrating models. Again, when you go to look at that menu option within the CABI, it tells you the next steps, right? So the first two obviously can be interchanged, doing your program order and then importing models, but we're going to go through the importing another model. So when we import ResSim, again, you can right-click in the modeling tree over here and say import on the ResSim tree, or you can go to the models, go to import, and then select ResSim. Again, as I said in the earlier presentation on the incorporating models, generally importing ResSim is recommended first because the stream alignment that ResSim has is a good thing to pull in first into your CABI the first time. So there are options when you open or import a model. You can either import the watershed or the alternative. And so if this is the first time you've imported a ResSim model into your CABI, you want to import the watershed. If this is not the first time and you're just trying to import a new updated alternative, then you can go to alternative. So let's explain what the difference is. The watershed itself, if you're importing, it's going to import everything. The stream alignment, there's configurations from the watershed setup and elements, your network, so there could be multiple ResSim networks, routing networks. There's alternatives. Your simulations are pulled in, any shape files like your maps, DSS files, and I think there's a few other things that get pulled in as well when you do the watershed. So everything that the ResSim model gets pulled into the CABI then. If this is not the first time that you've imported ResSim and you're just trying to pull in certain things, you may want to pull in the alternative. And when you do that, it does not pull in the stream alignment, does not pull in the configuration that you would have in your watershed setup. What you want to make sure is that that ResSim model that you're importing alternative is has the same stream alignment. If it does not have the same stream alignment, it might not reconcile the stream alignment that you have in your CABI if they're different. So be very cautious in that, because if you have a different stream alignment that doesn't cover the same footprint of the alternative that you're importing, you might get errors. If it is the same, and you know that it is, then it's just going to import just the alternatives itself. It's going to import the alternative that you need, and it's going to keep all those other files the same. So this is a good way to build a handoff, a ResSim model to a ResSim modeler for them to do additional operational operation sets. Maybe they can add some additional things within your routing network, and then you can import that as an alternative. So these are ways to upgrade your models as they are. But these are the difference between your watershed and alternative. Again, first time you do it, definitely import the watershed so you get all of these. And that's why I say always try to do the ResSim model first, because the stream alignment gets pulled in to your CABI so that you don't have to worry about that from the CABI itself. So revising your ResSim alternative for SWIMS. So either before, generally it's probably good to do after you import it, but you want to make sure that you set your lookback constraints in your alternative tab to map to a particular time series. So depending upon how the ResSim model was developed, they may have said we wanted to use a constant elevation for the lookback and a constant release for like the initial conditions, and they might have been looking at a very long time window when they were doing the analysis of setting up the rules stack and the operational constraints. So they might be doing like a year-long operation look for when they're developing the model. And if you're thinking about how you use it within SWIMS, you might be looking at a very short look back period, maybe a week, maybe a month at the most, probably. And you're probably doing a forecast window that could be only a week, maybe 2 weeks, probably no more than a month. So you're not going to look at the same time window that they looked at when they developed it. And you should, as a water manager, should have elevation time series and release time series. So we would want to map these to your look back time series. Now, not all offices archive or compute releases for every single outlet. They might just have a composite that this is the total release from the project. But your ResSim model might have all of those outlets in there. So if that's the case, just pick one of the controlled outlets that could represent enough of the outflow from that project and just use that as your time series. And then set all of your other outlets to 0. And I'll show this as an example here in a second. If you don't have time series or reliable time series for pool elevation or outflow, hopefully this is not the case for the core reservoirs you're operating. This is probably even more applicable to other reservoirs that are operated by other entities, whether it's a local water supply entity, maybe it's state-run, maybe there's another federal agency that operates it, maybe it's like a Bureau of Reclamations or another agency that's operating, you don't get all of the real-time data. There are advanced look-back options that could help you set those constraints based upon some information. So if you're looking at look-back elevation, you can set it just to guide curve, so it follows a guide curve when it's doing its look-back, so it's a little bit more representative of what you would expect to see from the reservoir. It could also be a reverse kind of calculation based upon a release. So if all you get is release from that entity that's operating that project, you can do a function of release, and all you need to do is give it a, okay, what is the initial start of the look back? Either it's a constant value, maybe it's a time series that you can put in there, and get enough information put in there, or maybe it's a guide curve. Just use guide curve to start with, and it can do a synthetic look back for the elevation. Same thing with the release. If you don't get time series of release, this is really kind of the reason this information was put in here, is because release sometimes is not available. It can be a look back based upon pool elevation. So if you have elevation of the pool but you don't have outflows, it will back calculate based upon storage curves that are defined in there what that release would have been to meet that elevation. So these are more advanced features. These features were also added for operating run-of-river projects like locks and dams. So check these out if you don't have information and you have reservoir networks that are in there that you're not in control of and don't have the data for. So looking at the operations tab, so when you do a drop down, here's what we're talking about. There's a constant look back, there's time series, and then here's all the other options that are in here for look back elevation. And then look back release, you can see here it's set to a constant. We generally like to set those to a time series or one of these other features. So you can see how these constants will have a number in here. It could be a pool elevation number if you were doing the constant. So we want to set those to a time series where possible, which might be a little different than the way they had developed the model. So you're working in real time, so hopefully you have data available to you to determine what the pool elevation and the outflows are at the projects. Once you have your alternative imported and you've set all the alternatives up, now we're going to start assigning model alternative keys. Once you get to the model alternative keys, you can have multiple ResSim alternatives. This is where you give the one character key, whether it's an alpha character or it's a numeric character. Again, you can only use that character once for the model. So ResSim can only use B one time. If you put B in here for this first one, you cannot use B anymore. I like to stress this again. Please don't overthink this. This is only going to be visible to you as the modeler when you look at the DSS record or we're looking at the CABI. No one's going to see this model alternative key, so don't overthink this. It's something to really think about too hard, but also know you can't go back and change this once you apply it. So think about it for a second, but don't overthink it. Once you do that, we're going to create a forecast run. So once you've created your model alternative key, you can start to create a forecast run. And so we can start to piece together in your third part of your, you'll have your MET view, your HMS, and then you'll have ResSim that goes in there, and then you'll have RAS or FI that may come in behind that. So we'll create a run. So for this example, this is going to just go through ResSim for this forecast run alternative. And then once we do that, we're going to start to do model linking. So model linking, more than likely, anything that's listed in this parameter as known flow, which is generally always in the top of the table, known flows are probably coming from HMS. So if you drag and highlight all the rows that have known flow, and then you go up here to select input model alternative, you'll have this dialog that comes up, and you can select from extract to go to HMS, and it will set all of those to HMS. The only times you would think that you would not have HMS for the known flow is if you're using RFC for your inflows. So if you're getting inflows from the River Forecast Center, those could be an extract time series. If you are doing that, if you're going to use an extract time series, be mindful that you have to have that data set for the entire simulation window, which includes the look back plus the forecast window. So you have to have the full run of a model to feed to a ResSim model for it to run, otherwise it will not run, which is why we generally put it at the HMS, because it should be matched in the same time window. But there could be reasons you might want to use RFC, but for applications of what we're talking about, we're going to map it to the HMS. And then anything that says look back elevation, look back release are generally always going to be extract list. There might be reasons where it might be linked to another model, but probably more often than not, it's going to be an extract. And then all that time series needs to be is to cover the look back period. So the start of simulation all the way up to the time of forecast. So once you get the time of forecast, you need all that data in here. ResSim is very much needing all the data. If it has any missing data, ResSim gets very angry. So that would be for any of the known flows or look back elevations or release. So you got to make sure that all the data is available. Otherwise, ResSim will throw red letters of death at you, if you will. Once we get the model linking done, then we're going to configure an extract. So the extract, generally you can select from the top up here. You'll select what you want from ResSim. It'll go down your extract, and you can create where you need to from your Oracle database or from the cloud, the CDA. It might also come from other sources as well. So maybe you have a local TSS file. I will caution, especially for whenever you're selecting the elevation from the record up here, databases that I'm most familiar with all generally have their elevation records in another datum, like 29 datum, and the models are developed in 88 datum. So if you have to run a script from 29 to 88, if you look in my extract list here, I have LEV parentheses 29. So that means there's going to be a script that's run. So if you select it from the top here, you cannot edit the destination. So this one's going to say specifically LEV. It doesn't have LEV 29. So I generally like to set up my extracts as ad hoc, but that's a user preference. But just keep that in mind. I always put my time series that I'm going to have in my CABI as one time series extract. You may want extracts for, I want an extract for ResSim, and I want an extract for HMS, and that's completely fine. It's user preference. I also like to have my flows that are coming from a project. I like to use this one time series to be mapped to HMS, to be mapped to ResSim, and to be mapped to RAS. I don't like to create 3 different ones of extracts for that same time series. The reason you have to do that is if they're named differently in HMS, if they're named differently in ResSim or in RAS. I go through and edit each model so that same time series is named the same in each one of those models. So that way I don't have to extract it one time. So once you extract it, we can do a compute. We can create a forecast and run it. And then when we do this compute, if you do it in the setup tab is a good place to do it to make sure that your models are running. Generally, you might run into errors, and the most common error you're going to run into is missing data. And if it has red letters, ResSim's pretty good at explaining to you what the errors are. So if you read through them, you'll generally have a pretty good idea of what the errors are. And for this example here, like I said, most commonly, it's going to be missing data. So it just says data is undefined. And it may not tell you the exact time. Sometimes it just tells you the time window, but sometimes it'll give you a good timing. So for this example here, it's giving me a decent time on where the missing data is at. And then if you read the DSS path name, it's this specific path that's missing data. And I need to go find that path in my forecast DSS file and see if that data is missing and why it's missing. So I may have to fill in data or go validate some data from the database. So, and then once I do that, I either can do that in a local forecast DSS file, or I can go to the database, do some data validation, and do a re-extract of the data into my forecast. So I can rerun the model. But generally, these red errors are mostly associated to missing values. If you have any questions about our software, need some help, or looking for additional training, check out these links. There's also these links are down below as well. Thank you for your time.